everyone, so in this video we're just going to discuss some of the differences between an orbit and an orbital. So there are a few differences between the two, and it's important that we realize them. So an orbit is a well-defined circular path around the nucleus in which the electrons revolve. Okay? So it is the path in which the electrons move around the nucleus. An orbital, on the other hand, as I discussed previously, is a three-dimensional space around the nucleus within which the probability of finding an electron is maximum. It's about 90 to 95%. So an orbit is really a path. An orbital is referring to probability. Alright, that's number one. Number two, an orbit represents the planar motion of an electron around the nucleus. So we're speaking of planar motion, and when we talk about an orbital, we're talking about the three-dimensional motion of an electron around the nucleus. Number three, the concept of an orbit is not in accordance with the wave character of electrons and uncertainty principle, and the concept of an orbital is in accordance with the wave character of electrons and uncertainty principle. So wave character and uncertainty principle. Number four, all orbits are circular and disc-like. So they're basically, orbit is just describing the motion, right? Again, it's not a physical entity. So all the orbits are described as circular and disc-like. However, orbitals have different shapes. So S orbital has spherical shape, P has dumbbell shape, G has double dumbbell shape, and so on. Right? So there are differences in shapes there as well. Orbits do not have any directional characteristics. Okay, there's no direction to their properties. An orbital, on the other hand, except for an s orbital, they have directional characteristics. So here, let me just write this down and I'll explain this. Except for s, others have directional characteristics. Right? So what I mean by that is S is just spherical. It doesn't matter on what coordinates it belongs, right? It's just spherical all along. However, p orbitals, as we'll discuss in just a few videos from now on, we can have three p orbitals. We can have one. So if this is my Cartesian system, X, Y, and Z, then this one is going to be along the y-axis, and I can have another one that is oriented along the x-axis, and then I can have yet another one that is oriented along the z-axis. So the direction does matter when it comes to p orbitals and d orbitals, but an orbit doesn't really care about that. Now, another important point is that the maximum number of electrons that you can have in an orbit is like the principal quantum number, right? It's like the n. So the maximum number of electrons you can have is 2n squared, and n is the number of an orbit, alright? That would be your max electrons, and the max electrons you can have in an orbital is 2. There is no formula, it's just a constant. You cannot have more than 2 electrons in an orbital. An orbit is the n value, the principal quantum number. So the maximum number of electrons you can have is 2n squared in an orbital. So if I had an n of 2, then the number of electrons I could have in that orbit would be 2 times 2 squared. That would be 8. Right? So those are some of the differences between an orbit and an orbital. I will continue this in the next video.